tomorrow we're going to do real full-blown problems. This is a baby one, just to get our feet wet. Okay, you have a circle that's decreasing in size. So basically we're looking at a circle who's constantly, we don't know, either getting bigger or getting smaller, but it's constantly changing in size. Okay, why? I don't know. Maybe it's a spotlight. I don't know. We don't have that context. Okay. But what does that mean when I say a circle is decreasing in size? What is changing?
Areas.
Area is changing, right? Okay, does everyone agree with that?
Yes.
Okay. So it's decreasing in size at a rate of 5 square inches per minute. This is a key word here. Because when I'm told rate, I know it's going to be one of those something DTs. Because those are all my rates. So let's think about it. When it tells me the circle is decreasing in size, that's telling me dA dt is kind of 5. When I say kind of 5, why?
-5.
-5. It's decreasing in size, correct? So dA dt is a rate. It's saying the rate at which the area is changing. So that's what it's telling me. The area is changing at -5 inches squared per minute. Agree with that?
Yes.
This is step 1. I'm writing down what I'm told. Now it says, at what rate is the radius decreasing when the radius is 4? Like, is there a typo there? I have people ask me all the time. No, there's no typo. Remember, we have a circle that's constantly changing. Actually, we know it's getting smaller, right? Yes. Circle is getting smaller and smaller and smaller. So it's saying that the radius is constantly changing, but at that one moment, at the moment the radius is 4, how fast is it changing? Is what it's asking. It's constantly changing, so 4 is not constant. But it's saying at that one particular moment when the radius is 4, how fast is it actually changing? That's the whole idea of calculus, remember? That how can you possibly have a speed at one moment when you don't change in time? So rates of change, slopes, tangent lines, secant lines become the tangent lines. So, what they're asking me to find, they want me to find the rate the radius is decreasing. So they're asking me to find what? In math symbols. dRdt. Rate. You know it's going to be some dt. And it's the rate at which the radius changes. They're asking me to find dRdt when r is 4. And it's important to note that this is not constant. So how can I relate my variables, which are obviously a and r? Area, which is r squared, correct? Which would be pretty obvious what formula you're using. So I have a lot of people, when they start these problems, plug in 4. But the problem with that is, if it's not constant, you cannot plug in until after you differentiate. I'll say that again because that's kind of a key point. If it's not constant, you can't plug in until after you differentiate. If it's not constant, you can't plug in until after you differentiate. So after I take the derivative, I can plug in all I want. But before I differentiate, don't you dare plug in anything that's changing. So now let's differentiate. What's the derivative of this? dA dt, 1 dA dt. Over here, my derivative would be 2 pi r dr dt. Now we're actually going to plug in our values. We're told dA dt is -5. R is 4 after the one moment. We've already differentiated, so now I can plug in. And I'm trying to find this. I'll go up here. With me there, I plugged in for R because after I differentiate, I'm allowed to plug in. Plugged in for dA dt. So let's clean that by -5 dt. Solve for dr dt. I have negative 5 over 8 pi equals dr dt. But we're not going to stop there. These are very important on these problems to have units. Now, I don't know what this decimal is. By the way, when you put this in your calculators at home, make sure you put parentheses around the bottom. I have a lot of people put negative 5 divided by 8 pi in the old calculators and get the wrong decimal. Because what that will do is it'll do negative 5/8 times pi. You know, but anyway, I need units. Remember we found dr dt, which is a rate. So what are my units?
Inches per minute.
Inches per minute. Just inches because we're talking a radius, not area. Inches per minute. The radius is changing at negative 5 over 8 pi inches per minute at that one moment. It's changing at different rates all the time, but at that one moment, it's changing that quickly. Yeah?
Yes.
We're going to have some big problems tomorrow.